Mysteries of Mars. Mars is the fourth planet and the furthest terrestrial planet from the Sun. The surface of Mars has an orange-reddish color because its soil has iron oxide or rust particles in it. The sky on Mars often appears pink or light orange because the dust in the soil is blown into Mars' thin atmosphere by winds on Mars. When the solar system settled into its current layout about 4.5 billion years ago, Mars formed when gravity pulled swirling gas and dust in to become the fourth planet from the Sun. Mars and Earth formed from the same materials and looked very similar. Mars is about half the size of Earth, and like its fellow terrestrial planets, it has a central core, a rocky mantle, and a solid crust. Mars is among the brightest objects in Earth's sky, and thus has been known from the ancient times. Mars is cold. Its average global temperature is around -80 degrees Fahrenheit, and has a much thinner atmosphere than Earth. Because it has about a sixth of the pressure of Earth's atmosphere, the planet doesn't retain heat very long, causing temperatures to drop quickly. Methane gas on Mars. The reported presence of methane in the atmosphere of Mars is of interest to many geologists and astrobiologists, as methane may indicate the presence of microbial life on Mars, or a geochemical process such as volcanism or hydrothermal activity. It is estimated that Mars produces 270 tons of methane per year. Based on photochemical models and on the current understanding of the composition of the Martian atmosphere, methane has a chemical lifetime of about 300 to 600 years, which is very short on geological timescales. How would we make fuel on Mars? Nearly all coal and oil on Earth and most sedimentary source rocks associated with coal, oil, and natural gas contain molecules of biological origin and is proof of past life. If Mars possessed an Earth-like biosphere in the past, Mars may contain subsurface deposits of oil and natural gas indicating past life. The bioproduction process would use three resources native to the red planet: carbon dioxide, sunlight, and frozen water. It would also include transporting two microbes to Mars. The first would be cyanobacteria, algae, which would take CO2 from the Martian atmosphere and use sunlight to create sugars. Mars have two faces. Mars may be home to the solar system's largest impact crater, hidden below lava. The impact itself, illustrated here, may have given Mars its unusual two faces, at high, cratered crust in the southern hemisphere and smooth, low crust in the north. Air on Mars. Mars does have an atmosphere, but it is about 100 times thinner than Earth's atmosphere and it has very little oxygen. The atmosphere on Mars is made up of mainly carbon dioxide. An astronaut on Mars would not be able to breathe the Martian air and would need a spacesuit with oxygen to work outdoors. But on Mars, carbon dioxide is 96% of the air. Meanwhile, Mars has almost no oxygen. It's only 0.1% of the air, not nearly enough for humans to survive. If you tried to breathe on the surface of Mars without a spacesuit supplying your oxygen, bad idea, you would die in an instant. A sustainable oxygen supply on the red planet can be achieved by converting carbon dioxide directly from the Martian atmosphere. A new solution to do so is on the way: plasma technology. Low-temperature plasmas or non-equilibrium plasmas are ionized gases where only a fraction of the gas is ionized. The results Sam spit out confirmed the makeup of the Martian atmosphere at the surface: 95% by volume of carbon dioxide, CO2, 2.6% molecular nitrogen, N2, 1.9% argon, Ar, 0.16% molecular oxygen, O2, and 0.06% carbon monoxide, CO. Water on Mars. Mars is rich in minerals that formed in water, and in some cases still hold water. These aptly named hydrated minerals can be found around the planet, as shown in maps made using data from NASA's Mars Reconnaissance Orbiter and the European Space Agency's Mars Express. The largest amount of water on Mars is unfortunately in the form of ice. So it is a long way from being suitable for human consumption. However, we need water for more than just drinking. Liquid water is also essential to produce fuel that would make trips between Earth and Mars more efficient. This is the thickness and amount of water would have if it were spread evenly over all of Mars. Taking what can be detected directly by spacecraft, scientists estimate that the measurable total of Martian water, in other words, its hydrosphere, is about 30 meters, 100 feet, GL. The Martian atmosphere today is so cold and thin that liquid water on the surface should either evaporate or freeze into the soil. For over 4 decades, though, Mars spacecraft have snapped photos of what look like hundreds of dried-up river channels and canyons that may have been carved by fast-flowing water in the distant past. Can plants grow on Mars? Plants will not grow as well as they do in Earth-potting soil, due to Martian soil's porous texture and lack of nutrients, but some will survive. Mars soil is not ideal for plant growth due to its granular and porous texture. On Earth, plants make the majority of the oxygen supply. On Mars there's a chicken and egg problem. The planet needs photosynthetic plants to make oxygen from carbon dioxide, but the climate must be warm enough and the soil conditions must be inviting to growth. Martian soil is harmful for plants and people because it contains a lot of chlorine in molecules called perchlorates. These toxic molecules will need to be removed before using the soil to grow food crops. The harsh Martian environment poses many additional challenges: plant growth. Martian soil is toxic due to relatively high concentrations of perchlorate compounds containing chlorine. Elemental chlorine was first discovered during localized investigations by Mars rover Sojourner, and has been confirmed by Spirit, Opportunity, and Curiosity. Is there rivers or ocean on Mars? Evidence from rocks and minerals. It is widely accepted that Mars had abundant water very early in its history, but all large areas of liquid water have since disappeared. Ancient Mars may have had its share of raging rivers. There are plenty of signs that liquid water flowed on the red planet long ago. But most of that evidence points to lakes, oceans, or relatively gentle streams, such as the ancient creeks uncovered by NASA's Curiosity rover in Mars' huge Gale crater. Mars is known for its crimson, frozen terrain, but a recent discovery from a team of researchers provides new evidence that there was once an ancient ocean on the now harsh Martian terrain. The discovery is evidence that Mars was, at one point in its history, quite different, a warm, wet planet. Some scientists believe there was a vast ocean in Mars' northern hemisphere. The planet's other features suggest river valleys, streams, basins, and deltas. In 2018, science reported that astronomers found an underground lake of liquid water below Mars' surface by using a radar instrument on the European Space Agency's, ESA's, Mars Express spacecraft. 3 new underground lakes have since been detected near the planet's south pole. The lakes are believed to be extraordinarily salty, however, so the water might not be drinkable even if the lakes can be reached. Life on Mars. Mars is believed to have lost its water when it lost its magnetic field around 4 billion years ago. Without an atmosphere, there was nothing to prevent Mars water from evaporating and then being lost to space. This radiation also made the existence of life at the surface of Mars unfeasible. Mars is one of Earth's closest neighbors, a mere 140 miles away, so it makes sense to ask if there was, or possibly still is, life on the red planet. There's no evidence yet, but NASA's Perseverance rover is searching for signs that microbial life, fossilized, microscopic life, may have inhabited Mars billions of years ago. If life does exist on Mars now, scientists believe it would be in the deep subsurface where conditions are warmer and wetter. Mars is potentially habitable several miles below its surface due to the melting of thick ice sheets fueled by geothermal heat. The main ingredient for life as we know it is liquid water, and signs of its presence on Mars have kept hopes alive of finding past or present signatures of life. But the Martian surface is a harsh place, with wild temperature swings and little protection from harmful ultraviolet radiation. Many scientists believe that dried-up lake beds like Gale crater could perhaps harbor fossils or other traces of past organic life near the surface, and NASA's upcoming mega mission, known for now as the 2020 Mars rover, will look for these kinds of traces. Meanwhile, extreme life forms on Earth, including signs of microbes living deep in the planet's interior, offer hope that something could be alive on Mars today. Can humans live on Mars? The race is on to send humans to Mars, with NASA aiming for a Mars mission perhaps by the mid-2030s, and public and private ventures around the world developing the necessary technology. But if humans are to survive at all on Mars, they will have to live and work independently of Earth, and carve out a living from the red planet's natural resources. Habitats will likely need to be built underground to protect people from dangerous cosmic radiation. Growing food on Mars will also be a challenge, as rovers have shown that the surface soil is sterile and full of toxic compounds called perchlorates. Ambitious space engineers are even now drawing up plans for the next generations of nuclear, chemical, and solar-powered technologies that will not only be able to advance science on Mars, but may also provide the foundation for self-sufficient human habitats. Building more efficient fuel cells and batteries will be necessary for surviving weeks of darkness during regional or global dust storms. Mining the dirt and rocks under their boots will be critical for making air to breathe, clean drinking water, rocket fuel, and basic building materials. Today, many Americans believe that aliens have visited Earth to help create the world, said Todd Thompson, USC Dornsife Professor of Anthropology and Communications. Interplanetary travel and space aliens are a very strong belief, parts religion and a sacred modern mythological story, stories that tell how the world was created or developed. On a cultural level, this is very hot stuff and explains how Americans view this. Up is like heaven, it has divine blessing, the notion that if we go there, we're doing something closer to the heavens and to God, he added. It's part of an escapist fantasy, to leave Earth and recreate a more perfect life somewhere else, the anthropocentric vision of getting off our planet to reach higher ground. Getting to Mars is not just about science, it is a cultural priority.